Pretty welcome. So in this problem, we are looking at the monopoly problem. So how monopolists maximize profit and why that's a market inefficiency as compared to a competitive, perfectly competitive market. So here we have the problem. The problem we have a cost structure where total cost, you can see up here, is equals to 2Q, and the demand is price equals 10 minus QD, which implies a marginal revenue of 10 minus 2Q. Here is the problem. And so in this case, we want to find first, well, we want to see how this marginal revenue function is derived from the demand curve. And then we can find marginal cost, average total cost, and then we can graph marginal revenue, marginal cost, find the monopoly maximization output and price, and compare it with the equilibrium outcome in a competitive market. So what we have here is the following. This is what we have. So let's first derive the marginal revenue. Since we know that total revenue is equals to P times Q, I can take this equation here, plug it into P, and I can find that Q times 10 minus quantity is my total revenue, which is also equals to 10Q minus Q squared. Okay, so now if you want to find the marginal revenue, it's simply the derivative of total revenue, right? So for derivative for Q, and I will find that applying the formula that we know, the derivative marginal revenue is equal to 10 minus 2Q. If you're not so sure about the rules of derivation, you need to go back and look at calculus. And if you haven't done calculus yet, don't worry, you will do it when you take a calculus class. So now let's look at finding marginal cost. How do we find marginal cost? This is pretty simple. We want to see what happens when we sell one more unit. And you can see, since the function is linear, that from the reference total cost, we find that each time we add one more unit, total cost goes up of 2, right? So it's pretty simple. I have here total cost, and I will have here quantity and total cost. And if for quantity, let's say 0, 1, 2, we can simply see that for 0 is 0, for 1 is 2, for 2 is 4. If you want to do 3, total cost is 6. So the change is always 2. Okay, so this is equals to the marginal cost, which, since there are no fixed costs, is also equal to the average total cost. So now I can start and graphing my stuff. So I start here again. I have here my price, sorry, my quantity, oops, my price, and I can graph the demand here. The demand is pretty simple. When price equals 0, quantity is 10. So I'm down here. And when quantity is 0, price is 10. That means at the price of 10, nobody will demand a thing. And so I will have my demand, which is like this. Now I have here my marginal revenue, which is simply double the slope, right? Because every time every extra unit, it decreases my marginal revenue as 2Q. And so it will be 0 will cross when it's equals to 5. You can simply set up to 0 and find that Q equals 5. So my marginal revenue will look something like this. That's my marginal revenue. Now I can easily graph my marginal cost. My marginal cost is equals to 2. Oops, I don't know what's happening here, is equals to 2. And so since this is equals to 2, I can simply find here 2, and that's my marginal cost. Now, I simply can find where marginal cost equals marginal revenue to find the profit maximizing output. So I set up marginal cost equals marginal revenue. I know the marginal cost is 2. I know the marginal revenue is 10 minus 2Q. And now I can simply solve it. I'm not going to do all the passages. You know how you can move the thing on the other side, but it would be 2Q equals 8, which gives us Q equals 4. So here is the quantity as 4 is the profit maximizing quantity for a monopolist. Now here comes the key. What price can they charge if they make per unit? I need to use the demand for that, okay? So since I know my demand, and my demand again is the one that was up here, P equals 10 minus Q, I can easily find if my Q is 4, I can find that 10 minus 4 is 6. I can charge a price of 6. That's what it means. It simply means, 6. It simply means that if I make 4 units, I can charge $6 per unit for these units, and that's my profit maximizing point. Can I verify that? Yes, of course you can. You can simply plug in 5 5 units, find a new price, 3, and compare total profits. But assuming you have done that and you understand why, now we can find the total profit for the monopolist. Total profit for the monopolist is simply the profit per unit, which is this level here, $6, the price that I sell it, minus 2, the price for making it, which is 4. So total profits will simply be $4 per unit times 4 units would be 16, and is this area here. Okay, so this is how the monopolist does. Now, let's say we open it to competition and the price is 6 and 4 produced. Another company comes in. You probably have seen examples of medications. Until there is a patent, this will be the price. Now generics come in. What happens then? They start to compete on price. So the other company makes the same thing, sell it at a lower price. And so you'll have this effect here. You will have lower price. That means more people will want to buy it. You will have a higher consumption. And this process will continue until you reach the point here where you have the perfectly competitive long-run equilibrium where there are no economic profits. So the cost of making it is equal to the price that will be sold, no economic profits, this will be accounting profit, but it's clear that at this point, the price will be equals to the marginal cost, which is also, we said before, in this case, equals to the average log cost, which is equals to 2. Then again, at the price of 2, I can use my equation. I plug in a price of 2, and I will find that the quantity is 8 for the price of 2. Okay, so this quantity will be 8. So now I can easily compare the two outcomes. So for monopoly, price we said will be 6 and the quantity will be 4, while for perfect competition, price will be equals to 2 and quantity will be equals to 8. So you can clearly see the benefit of competition versus monopoly for the consumer. Now, if you think about consumer surplus, in terms of, in the sense of competition, this big triangle here, 2, 10, and 8 is my total consumer surplus. What a monopoly will do will reduce consumption here to 4. Oops, sorry, again. So it will be reduced consumption here to 4. Sorry, I don't know what I'm doing here with this. Boom, let me do this. So it would be consumption will be reduced here to 4 at this point here. So this is gone. This area here is deadweight loss. This is deadweight loss. And you can easily calculate the area. Here is 6, here is 2, and here is 8. Calculate the area. And the consumer surplus will be reduced to this little area here, where now, if you have monopolist, 6 is the price for the quantity consumed. Only these people will get it that are willing to pay more than 6. And this would be the consumer surplus. So this is the monopoly problem, and hopefully that's helpful. And thank you very much.